Welcome to the lecture on automatic control system. In this lecture, we will discuss about performance specifications. So, we saw the definition of the control system, that a control system should give a desired output with desired performance for any specific input. So here desired performance, when we say desired performance, there should be certain parameters that measures the performance. So whenever we design a control system or we analyze a control system, we should have certain objectives. So what is a design of control system? So in a design of a control system, we create systems of performance. So design is what? We want the system to give certain performance and we are going to design system for that. So therefore, a design is a process through which systems of performance is created or changed. Changed means if we have already an existing system and we know that the system is not going to give the desired performance, then we need to change the design of the system so that it is going to give an improved performance or desired performance. So we are going to change the design. In contrary, analysis is a process through which we determine the system's performance. Means once we design a system with the objective that the system that is designed will give the performance that we define at the beginning of the design. Now whether it is going to give that or not, this is done by analysis. So analysis is a process through which the system's performance is determined. So every control system, there is certain analysis and design objectives. When we go to design a system, we should have certain objectives that the system should achieve. We know that from the response of the elevator that we saw that elevator response with time this is the input and this is the output or response. So this is the transient part, this is transient and this is steady state. And there is the error, this is the steady state error. So we see that this part which is transient and steady state. Therefore, we should have certain design objectives for a control system. Whenever we try to design a control system, we should define the objectives of the design. So objective of the design should be based on three main characteristics. First is the transient response. We should achieve desired transient response because the control system's definition is we should achieve the desired output with desired performance. So we should get the desired transient response, we should get the desired steady state response. And then the third parameter that we are going to add is the stability. And therefore, the based on these three objectives, design objectives, we have the performance specifications. These are the parameters through which the system's performance can be assessed. We can talk the system's performance in terms of these three parameters. That is transient response, steady state error, and stability. So now we understand that these three things, they comes into the design and they are going to appear in the performance. So that's why we call it performance specification, because from the response we are going to decide whether the system, based on these three parameters, the system's performance is correct or desired. There could be some other considerations that also we will discuss. So let's discuss these three parameters, three specifications one by one. So the first design objective should be the transient response. The first design objective of a control system is a transient response. We know that if this transient response is very fast, if this transient response is very fast for this elevator, it could be discomfortable, uncomfortable, or it can also damage, physically damage to some person or some parts of the system. And if this is very slow, it will, the person will sacrifice it will sacrifice its patience, person's patience who are in the lift or elevator. So therefore, when we set the design objective, we should, in the beginning, we should define that what is quantitatively, that what is the transient response objective. How fast I want the response. What should be the characteristics of the transient response? For example, this system, how fast we want, when we want to reach this end, this transient response, because this transient response can be also like this, or it could be this. So whether we want this or this or this or this. So you see, in this case the transient response is very fast. Suddenly the lift is rising, the elevator is rising to the follow the input, and it is very risky as well. However, this takes much time, this transient response, so it increases the waiting time. So therefore, quantitatively we should define that how much this time, in terms of time, or some other parameters, because these parameters will depend on the type of the system, whether it is first order system, second order system, or higher order system. So these systems have different parameters for this transient response, and so these parameters should be defined quantitatively. And then if we have a new system, we should set these parameters and we should go for the designing of that system. Or if it is an existing system, then we should decide that how much change we should do in the system to get this particular transient response. And then once we have set the objective of the transient response, we will adjust our parameters, or we will change the parameters of the system so that it will yield a desired transient response. So the system has its own parameters, and we change the parameter, that transient response will change. So once we have this objective that this much change in the transient response I want, or this much transient response I want to generate, we will change the design, we will change the parameters so that the system is going to give that particular transient response. So this is the first design objective. Now the second design objective is the steady state response. This part, second part, so this part. So now this steady state response is what that remains after the transient part has been decayed. So you see, once transient is, this is transient, then when transient is gone, what we get is the steady state response. So steady state response, how it affects the functioning of a system. So you saw that in case of elevator, let me redraw this diagram. So we can see that this steady state response, this difference is steady state error. And this steady state error means that there is a difference between the labeling of this floor and the actually we are reaching through the elevator. So this difference is more, means we are away from the floor that much. So the steady state error should be minimum, and that is the good response if the steady state error is minimum. So steady state error is one parameter that can be allowed to control, or that could be a design objective. So we should define that when we want to design a control system, we should define that quantitatively, that how much steady state error we want. What should be the range of the steady state error of the response of our system? So once we have defined this steady state error, we should analyze. If we have a new system, it's okay, we go on so that we can get this steady state error value. But if it is an existing system, we should check what is the steady state error of the current system, and then how we can change the system so that we could get the desired steady state error. Okay. And so this steady state error is the second design objective, and as well as this is one of the performance specifications. Now we come to the third objective, third design objective, and that is stability. Now what is stability? So let's discuss what is stability. So stability, you know that if we have a system like this, so if we have a system like this, spring mass damper system, and it is subjected to certain force input, certain input, that is a force, harmonic force, we will get the differential equations mx double dot plus cx dot plus kx equal to f0 sin omega t. When you solve this equation, so this x will be xc plus xp, that is complementary function, and this is particular integral. So this xc is a component that is also called natural response, and this is a response due to the applied input, that is force response. And this is the x is the total response. So what we see that for a dynamic system, if there is some input, some force or some any other type of input, the system's response is of two components, that is natural response and forced response. Now why we call it natural response? Because this response depends on the property of the system. So if we try to plot for this system the response, let's assume that this damping C is under damped system. So C is less than critical damping. So this is an under damped system. For under damped system, if we give this response, this will so this is xc and this is time t. So this is the natural response. Now xp or force response so this expression x is given as a1 e power minus okay. So now we can understand from this this is a solution of this, and this is xc and this is xp. So we can see that here it is exponentially decaying and with harmonic function. So this is a harmonic function and the amplitude is decaying exponentially. So this is xc. Now this is a sine curve. So this is a sine, because this is a sine function. Now when we will get the x with time, so x will be the xc plus xp, and so this is the superposition of these two functions. So we add them and we will get something like this. So in this you can see that this part, this sinusoid is, when we add it, it is not the pure sinusoid, it is disturbed due to this part. Once this part is decayed to 0, we are going to get what is the xp. So x is equal to xp after certain time when this x is decayed to 0. So here when we talk stability, we talk in terms of the natural response. This is natural response. So a system is stable if with time its natural response approaches to 0, and after certain time the total response of the system will be the forced response. Suppose the natural response is not decaying to 0, but it is like this. So with time this natural response is growing. You see the amplitude is growing. Here it is decreasing, but there it is growing. So it means natural response is growing, and so if you will superimpose this forced part to this response will be again growing without any limits, without any boundations. So this is the unstable condition. So if you are in an elevator and the elevator's response is growing very fast and growing with in amplitude, the elevator can hit to the floor below the ground floor, or it could hit to the ceilings. It can go out of the ceilings after breaking this. So if a system is, it will crash to the floor or ceilings. So therefore, if a system is unstable, it is very dangerous. It can make certain damage. And so stability is the third design objective, and it is very important objective, very much important, because if the system is not stable, there is no any use of talking the steady state error or transient response, because the system will not follow the input, because system is out of control due to its own internal characteristic, and therefore there is no meaning of talking the steady state error of this type of system. So when we talk about third design objective, stability, we should be clear that the natural response of the system should approach to 0 after initial time from the starting of the response, and then only the system is stable, and the system will reach to the steady state value. Otherwise, if it is not stable, we can't expect any steady state value, steady state response. Now, some other design considerations that we should discuss. So other design considerations, the first one could be the finance. Finance means the budget that is allocated to design that product, that control system, and the competitive prices, the product that will emerge to the market, whether it is competitive to the already available products or not. If it is not competitive and it has not some advantageous features, some advantage, then this control system is not going to be sold out. Therefore, it is important to consider these finance as another design consideration. Any design should have certain limited cost. The last one is robustness. So what is robustness? So you know that when we design certain system and we are going to actually manufacture that system, there is some difference between what we design and what we get from manufacturing, because there is certain limitations of the manufacturing processes that they can't produce exactly what is designed. There should be some differences, some difference in tolerance, some difference in material properties, and some other parameters. Therefore, we are not going to get the same parameters that we are designed. We will, if we design for some values that the spring, there is some spring and spring constant should be 1000 kilonewton per meter, but it could be maybe 1010, 1050, something like that. If there is some little change in the parameter, the control system's performance should not be affected. It should be not so much sensitive to little change in the parameter. Therefore, a robust system is the system that has less sensitiveness when there is some change in parameter. Suppose it is designed for some temperature, room temperature, 27 degrees Celsius, and if temperature goes to 40 degrees Celsius, it is not giving the desired output or desired response. So this system is not robust. A system is robust if it is designed for 30 degree, it can give at the same performance at nearby temperature values. So that's why this robustness is another consideration that a designer should consider in its design objective. So what we learned that this design objective should account the transient response parameters, steady state response parameters, and stability parameters for their design, and the same thing are the performance specifications, because that you will get after the analysis of the system or after the system is designed. So here again, the reference books we are following is Norman S. Nice from Control System Engineering and K. Ogata from Modern Control Engineering. So I thank you for this lecture, and let's see in some next lecture. Thank you.